Hello everyone, this is Bradley. So quite a while ago, I found a very interesting animation on Twitter, and that animation has been posted in the link in the description. I highly recommend you to take a look to that because it's a very interesting animation. However, I have no idea how it has been done. So if you have any thoughts, feel free to share your idea in our Discord server using the link in the description. On the other hand, today our work is to make a much simpler replicate, which is inspired by Cinema 4D. So let's start. So here we in Blender, let's go to noding, create an object and a geometry node tree. We are going to start with a triangle, a procedural triangle. But how to do that? Maybe we can start with a mesh circle and take the vertices to 3, and we just make that into Hexagon or whatever other stuff because we do not need any subdivision. Okay, and then we're going to offset that. The easiest way is probably take a transform, but we need a bounding box vector. Take a bounding box, and there will be a minimum. We do not need to use all the minimum to offset the entire thing. So I'm just going to take a vector mass like this and to multiply its values. And we realize that if I take a -1 in the minimum, then it stays on one end, which is already good. Okay. The reason I'm doing this step is to make sure that my object is staying at its origin. Okay, so can definitely Control G to group that together so that we form these units that we are not going to worry that later. So we can just call that as a triangle. Okay, and if we try to use the transform, then you can see it's always rotating at this new origin we've assigned. Okay, and this will be equally true when we try to instance that. There are 2 levels of instances that we are going to do. The first level is to instance at its original location. So we take a mesh line and we can set the count to whatever number you like. Maybe 10 is good enough, but this is not the original location, so we're going to cancel the offset. Right now we have overlapping geometry. That's why even we are rotating that, it looks like just a single triangle, while there should be at least 10 triangles. So what we can do here is we're going to create a mix factor so that we are going to assign a destination of its rotation. I think it's -pi. So by manipulating this factor, we're rotating this single triangle. But assume if we are trying to plug in a delay fold, usually this is probably the fastest method. And by playing this animation, then we can see there are differentiation of rotation for all these kind of cards or pages. Next, we're going to move on for second level of instancing. There are probably many different sites that you can instance. You can instance it here, here, there. But I think the only correct way is to instance it here for our future detailed manipulation. So here, what we're going to do is there is a very specific pattern that we're going to use. That's called the Hexagon distribution. People also call it a honeycomb in Cinema 4D. But anyway, the whole point is that you need to get this distribution in which all these kind of origin can essentially form kind of a hexagon patterns. And you can repeat that. Okay. Here, I do not expect you to learn all this kind of mathematical functionality, because it's kind of useless. You can just take this node and use that. What's very important here, however, is that making sure that since you're instancing your triangle as the last step, so you can always rotate all these kind of pages or cards without any problem. That's the important part. Here, since we're not going to use all this kind of rotation and scale of our first instance on point, so I'm just going to select the node and hit Control H to collapse the node to make the node tree cleaner. Next thing I'm going to worry about is I'm going to turn down the count so that the setup is easier to observe and manipulate. And then now, by playing this animation, we can realize there is no randomization from instances to instances. And usually what we do is to plug the geometry into this random index. And once we do that, playing this animation, we can see the randomization, but not from instance to instance, but rather from pages to pages. Okay. This is not what I'm looking for. I want a kind of consistency from pages to pages, but randomization across instances. So we're going to do this a little bit differently. Due to some reasons, I'm going to reconstruct this delay Falloff using an alternative method. So we need a time to trigger this animation. And because this time goes from 0 to whatever other current time values, and then you can see this animation, but this animation is not being clamped. So we're going to clamp this factor so that this animation always goes between 0 and 1. After we having done the triggering, we need to also done this kind of offset. We can use the offset by subtracting a float range. And this float range is basically adding one value for every component. And now you can see this animation. We can turn down this step size so that the pages are being flipped faster. But right now, there is still no any differences from instances to instances. So there are several things we're going to do. Firstly, I'm going to realize these instances so that all instances are different. Okay, but now because we are adding one for every component, so there is a kind of a sequential effect for all of them. What I'm going to do is to take an attribute instance, which is equally true to just the capture attribute in the instance domain, and then we are going to capture the index so that we get an index for every instance and plug that into the group index. Right now, if we try to play this animation, then you can see every animation is being synchronized. Right now, you might be wondering, we've added so many new nodes, but we haven't done anything new. This is exactly the same result when we have all this kind of delay Falloff previously. The reason I'm doing this is because knowing that this animation is essentially being triggered by a time frame and a offset for every instance, which means if we manipulate this kind of time by adding or subtracting, that we are speeding up or delaying this entire animation. Okay, so if we're having a new random value for every instance, then we have a differentiation of delay. What we can do here is to add a random value node, and we're using instance index to drive a random number or random delay for every of them. So now if I try to play this animation, then you can see there's a differentiation, but there's a consistency between pages. Here I want to remind you that there is a math node inside this time info node, so that we're controlling the time more precisely with a kind of rate. Since we're running the division with a factor, which means larger the division, then this entire animation, that's lengthening the entire duration of this animation. And if we play this animation, you can see their rate is very slow. Okay, and if we try to decrease the factor like 5, then this animation will be extremely fast, as you see. So this means that we can not only delay this animation using all this kind of simple math, we can also try to add a just kind of random value into this factor as well. Personally speaking, I'd like to use a randomness node, so that instead of dealing with all this kind of minimum and maximum, with this factor, we can determine the average of our variances. So the average will be about 25, and the variances is about 50% from this 25. Okay, and by doing that, there should be some of parts is faster, some of part is slower, and we can play this animation. Hopefully we can see the effect. Yeah, I think we see that roughly. Okay, so it's kind of very chaotic. Some of definitely I forgot one thing, that I forgot to put this index into the custom ID, so that there was a kind of inconsistency from pages to pages. But so now it looks kind of better in my opinion, but it's completely up to you how you would like to manipulate all these kind of parameters. I'm just speaking that there are lots of parameters that you can play around with just a kind of simple math, because it's just a subtraction, and within this time info node is really just a multiply. Everyone knows plus, minus, multiply, and divide, I suppose. Okay, so up to this moment we've basically finished this animation. The rest is about the kind of shadings and filling these gaps in between. In fact, I haven't watched the original Cinema 4D animation, so I don't know how they have done that. But there is essentially probably plenty of ways. So for example, I want to have a solidify, and let's take a set material. The solidify is essentially just trying to extrude the face on two sides. I don't think this is a perfect solidify node, but it does give us the thickness if you want. Okay, and let's set materials. What's very important is you can output a backface as the attribute, and in order to really access all these kind of faces, we're going to realize the instance. So then we go to shader, just to take an attribute node, type in B attributes, mix RGB, we can set white and red, and plug in that into the base color. And within material preview mode, we can see the positive side is white and the back side is red. If I turn off this realize instance, then it will not work. Another way that we can potentially do is to use the geometry backface. It's usually working for a single plane, and you see it's working in this particular case. I think it's only because I implemented this solidify wrong. So please do not rely on this, because the result might be changed in the future. I'm not sure if, yeah. The only benefit is probably at this moment to realize instance is not mandatory, so that you can save some performance, because the realize instance can be quite heavy. But this is 0.27 milliseconds, you probably do not really worry. To fill the gaps in between, the method on the top of my head is basically just to do the instancing. So let's Control Shift H, actually Control H to collapse all these kind of node groups, and Control Shift D to duplicate this node group with linkage. Okay, so one of that will be negative 180 degree, the other will be 0, and we are going to join geometry 1, 2, and also I'm going to set the material. This time we are not going to realize the instance, because I'm going to give them a unified material. So within our material, I'm going to Control G to make this mixing node into a group, so that I can share these colors in different shaders. So let's call that mixing. And I'm going to create 2 sockets and 2 new materials. So all of them are using the mixing. But within the material 1 and 2, I'm going to change the vector. Instead of using the back facing. And then I think this is 002, this is 001. So now if we go back to our starting of the animation, you can see there's a white and red. There are some overlapping geometry which can potentially mislead you about the result. But if you look individually, you should get a kind of idea. So this should be white. and that should be red. Okay, so now if we look at that, it's still wrong. This is because of overlapping geometry. So we're going to set the position, which is just a 0, 0, 1, so that the white parts can be selected by the render. So now if you try to play this animation, you can see there's a white, red, and this animation is basically being fixed. Okay. There are many other things that you can potentially tweak to make this animation loopable or whatever other stuff, but basically this is kind of idea. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.